Okay, so this is just going to be a review of solving quadratic equations by using the square root property. So in previous lessons, we saw what this involved, and this is just some problems that I worked out just to review how to use the square root property. Now, before we begin, just remember that we are dealing with quadratic equations. And so in a previous lesson, you learned about the fact that a quadratic equation has this form. Okay, so a quadratic equation is an equation that can be written in the form and we ax squared plus bx plus c equals 0. All right, now the other thing you got to remember is that the coefficient of x squared, a, cannot be 0, because if a was 0, then you would no longer have that x squared term, and this would be a linear equation. All right, so b can be 0, c can be 0, but a cannot be 0. So a, b, and c can be any real number. A, b, and c are real numbers, but a cannot be 0. Okay? Now, for us, though, in this particular lesson where we want to use the square root property, it's going to involve this idea. So if this quadratic equation has this form, so if we have this quadratic equation where we have x squared equal some constant, all right, it's still quadratic because you notice that the largest exponent you see is 2, so x squared, so that's quadratic. So this is a constant though, so notice that the x term's missing. So an example like this would be x squared equal 16. All right, so that's what we're referring to here. So this looks like this, okay? Now, if we have x squared equals c, so some expression squared equal a constant, then to get x by itself, to solve for x, I can take the square root of both sides. Okay? And so when I take the square root of both sides, don't forget the plus or minus. So basically, the square root and the square term undo each other, and so you get x equal a positive square root of c and a negative square root of c. That's what that says. So we could also write it as x equal plus or minus the square root of c. Now, in my math lab, they're going to want you to separate it using commas. So over here, if we look at this, see where I have x squared equals 16? You can look at this equation and very easily determine what your solutions are. So what number times itself is 16? Well, x equals 4. 4 is a solution because 4 times 4 is 16. But also negative 4 because negative 4 times a negative 4 is a positive 16. Okay? So based on this property, what you want to do is say if you have x squared equals 16 and you take the square root of both sides, don't get the plus or minus, the square and the square root undo each other, so you get x equals plus or minus 4. Or you can say x equals 4, comma, negative 4. Okay? All right, so the directions will say, in this particular review, the directions will say solve each equation by using the square root property. All right, using the square root property. All right. So number 1, let's say we had x squared minus 18 equals 0. All right, so x squared minus 18 equals 0. So if I'm going to use the square root property, basically what's going to happen is that the x term won't be there. So you'll just have an x squared and a constant involved. That's basically what's going to happen. All right, and that's what you have here. You see, you don't have an x term. You have your square term and you have your constant. That's it. The x term is missing. So in that case, what you want to do is you want to rewrite it to make it look like this. So you want to get x squared by itself. So I'm going to add 18 to both sides, and when I do that, I get x squared equal 18. Okay? Now, the next step is to take the square root of both sides. So take the square root of both sides. I'm going to go ahead and rewrite this over. And then don't forget, when you take the square root of both sides, you get plus or minus. So I get x equals plus or minus the square root of 18. Now you are asked to reduce if possible, or to simplify, rather, simplify if possible. So if you look at square root of 18, there is a perfect square that goes into 18, and always use the largest. So the largest perfect square that goes in 18 is 9. So I can write the square root of 18 as the square root of 9 times 2. And then I can rewrite this as the square root of 9 times the square root of 2. And the square root of 9 I can simplify as 3. So that's 3 square root of 2. So my solutions are x equal plus or minus 3 square root of 2. Or on my math lab, you'll say 3 square root of 2, comma, negative 3 square root of 2. Okay? All right, number 2. Number 2, let's suppose in number 2, we have this. We have 5x squared minus 125 equal 0. So 5x squared minus 125 equal 0. All right? Okay, so remember you have to get in that form. So you have to get x squared by itself. So if you're going to use a squared property, you have to get x squared by itself. And on the other side, you just have to have a constant. So basically, you need to look at this and ask yourself, can I use the squared property here? Yes, because the x term is missing. There's no x term. You see an x squared and a constant. That's it. All right, so first thing you're going to do is add 125 to both sides. So I get 5x squared equals 125. Then you get x. Remember, you don't take the square root of both sides just yet, because you're probably going to mess up if you do that. Get x squared by itself first. So let's divide both sides by 5. So I'm going to divide by 5. 5's divide out, so you get x squared equal, and 125 divided by 5 is 25. Okay? All right, so I'm going to go ahead and rewrite this over. Now, you can look at this and guess what the answer is, but let's actually do the work. So the next step is to take the square root of both sides. All right? Don't forget, you got a plus or minus, so I would write that now. So these undo each other, so you get x equals plus or minus the square root of 25. But simplify if you can. Notice that 25 is a perfect square. So since 25 is a perfect square, this becomes x equal plus or minus 5. And that's your solution. And let's just check 5. What's 5 squared? 25. What's 25 times 5? 125. 125 minus 125 is 0. If you do negative 5, what's negative 5 times itself? 25. 25 times 5 is 125. 125 minus 125 is 0. All right. Now, in my math lab, you will be asked to separate them using commas, so it'll be like that. All right, number 3. Let's suppose in number 3, you have 6x squared minus 240 equals 0. So 6x squared minus 240 equals 0. Okay, well, it's just like number 2. First of all, you need to get x squared by itself. And so I'm going to add 240 to both sides. And so I get 6x squared equals 240. Now you get x squared by itself. You got to do that first. Don't take the square root of both sides. Because you're going to forget about the square root of 6 that you're going to end up with. So divide by 6 makes it a lot easier if you do that first. So get x squared equal, and then 240 divided by 6 will give us 40. All right, now the next step, I'm going to go ahead and rewrite this over. So the next step is to take the square root of both sides. Don't forget, when you take the square root of both sides, you get plus or minus. So the square and the square root undo each other. So you get x equal plus or minus the square root of 40. Now remember, the direction says simplify if possible. I can simplify this because what's the largest perfect square that goes into 40? The largest perfect square, remember your perfect squares are 1, 4, 9, 16, 25, 36, and so on. Okay? Because the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3, the square root of 16 is 4, and so on. So those are your perfect squares. So besides 1 goes in all, every whole number. Which of these perfect squares, which of these is the largest that would go into 40? 4, right? Okay, so I can write square root of 40 as the square root of 4 times 10, right? And then the square root of 4 times 10 I can write as square root of 4 times square root of 10. So that's 2. Square root of 4 is 2, square root of 10. And so I get x equal plus or minus 2 square root of 10. All right, number 4. All right, number 4, let's suppose we had this. All right, we have x minus 3 squared equal 12. All right. Now, remember that when we did the other ones, we used the property that if x squared equals c, then x would be plus or minus the square root of c, right? You take the square root of both sides. But remember, though, this property, you can expand it a little bit further to this idea that if you have some expression squared equal a constant, then that same thing applies. So you may say, well, I don't see an x squared here. I see an x minus 3. It doesn't matter. It's still this idea where you have some expression squared equal a constant, then take the square root of both sides. And I have that here. So I have some expression squared equal a constant. So what I'm going to do is I'm going to take the square root of both sides, plus or minus. All right, now the square and the square root undo each other. So you get x minus 3 equal plus or minus the square root of 12. Before you go any further, remember the whole idea is to get x by itself, but before you do that, you have to remember, let's go ahead and simplify the square root of 12. So let's talk about the square root of 12. What's the largest perfect square that goes into 12? So remember, list of the perfect squares here. What's the largest one? 4. Because 4 times 3 is 12. So I can write this as the square root of 4 times 3, which is square root of 4 times the square root of 3, and the square root of 4 is 2, so that's 2 square root of 3. All right, so that right here, this right here, instead of saying plus or minus square root of 12, this becomes x minus 3 equals plus or minus 2 square root of 3. And then the next thing I got to do is get x by itself, and so I'm going to add 3 to both sides. Now be careful, don't make the mistake, because that is a common mistake people make. They want to say that's going to be 5 square root of 3. That's not true. So I want you to remember this. So note some errors people are going to make. So when I do this, when I have plus or minus 2 square root of 3, and then all of a sudden I say plus 3 because I'm adding 3 to both sides, that is not 5 square root of 3. That is incorrect. You learned in a previous lesson that these are not like terms. It would be 5 square root of 3 if I had something like this, 3 square root of 3 plus 2 square root of 3. See how both of these terms have the square root of 3 in it? Then that will be 5 square root of 3. All right, so don't make the mistake and say that's 5. All you're going to do is say this. So combined like terms, you're going to get x equal 3 plus or minus 2 square root of 3. That's what you're going to write. All right, so 3 plus or minus 2 square root of 3. Now, remember, this actually represents 2 solutions. So on my math lab, you're going to write it like this. You're going to say 3 plus 2 square root of 3, comma, 3 minus 2 square root of 3. That's how you're going to write it. So 3 plus 2 square root of 3, comma, 3 minus 2 square root of 3. So those are your solutions. All right. Now, I just want to show you something. If I approximate this, so just using a calculator, I just want to show you something. So if I approximate this, 3 plus 2 square root of 3, so watch, 3 plus 2 square root of 3, and then press equal. To 2 decimal places, see where that's 6.46 right here? So that's approximately equal to 6.46. I'm not going to write it down because I'm not going to write that down, what I just have in that calculator, because I don't want you to think that it's okay to write it as 6.46, which is not, because the directions did not say anything about rounding off. All right, so those are your solutions. You are done. What I'm telling you, though, is that I want to approximate this one, 6.46, although, remember, it's not equal, it's approximation. In fact, let's just go ahead and use the nearest thousandth, 6.464. And I'm going to go ahead and plug that into here and see if this side is going to be equal to that side. Now, it won't be equal, it'll be approximately equal because I'm rounding off. So 6.464, right? Okay. So parentheses, 6.464 minus 3, close the parentheses, I'm squaring that, and then let's press equal. Hopefully it's very close to 12. And it is, 11.999, and so on. Okay? All right, so remember, on MyMathLab, you're going to separate them. So those are your two solutions. One is this, one is this. Now remember, we talked about these being irrational solutions. So those are irrational solutions. So in the irrational solutions, you end up with these square roots. Okay, so in number 2, when we did number 2, remember, and we talked about this idea in previous lessons, these are rational solutions because those are rational numbers. This is an irrational solution. You have that square root. That's an irrational solution. So you cannot simplify this. You may say, well, you have a square root there. Well, yeah, you're right. I do have a square root there, but that square root of 25, 25 is a perfect square. I ended up with a positive 5 and a negative 5. Those are rational solutions. Those are rational numbers. Here, when I simplify this, 40, see that 40? 40 is not a perfect square. So I'm going to end up with irrational solutions. All right, so just go back. If you don't remember that, go back to those lessons we talked about. All right, so that was number 4. Number 5, let's suppose we had this. X plus 4 squared minus 3 equals 17. All right, so think about how you're going to go about approaching this. Because remember, you do want, the direction says you must use a square root property. So then, what that means then is that I've got to get it to look like this first. So this is what I have. So what do you think you may need to do? Well, remember, you got to get this by itself first, right? So you got to do what here? You're going to have to add 3 to both sides. All right, so let's go ahead and add 3 to both sides. And so when I combine like terms, I get x plus 4 squared equal 20, right? All right, so now I have something that looks like this. So now I'm going to take the square root of both sides. All right, so I'm going to take the square root of both sides, just like this, plus or minus. Now don't forget, I got to simplify the square root of 20. 20 is not a perfect square, but what perfect square goes into 20? All right, 4 again. It's selected every one we're using is 4. All right, so 4. So I know that square root of 20 is going to be the square root of 4 times 5, right? And that's square root of 4 times square root of 5. And then simplifying the square root of 4, since 4 is a perfect square, I get 2 square root of 5. So this becomes, remember the square and the square root don't do each other, so this becomes x plus 4 equal plus or minus 2 square root of 5. All right, now remember this is irrational now. And so one more step when you're done, you got to get x by itself. So subtract 4 from both sides, just like we did here. And so combine like terms, I get x equal 4, negative 4 rather, plus or minus 2 square root of 5. Now on MyMathLab, remember there are 2 solutions here, but on MyMathLab, they're going to ask you to separate your solutions. So you're going to say x equal negative 4 plus 2 square root of 5, comma, and then negative 4 minus 2 square root of 5. Okay? All right, number 6. Suppose number 6, we had this. We had 3x plus 1 squared equal 15. So 3x plus 1 squared equal 15. Okay. So So I already have it in that form, don't I? Where where I have where I have something squared equal a number. So always think like this. You need to ask yourself, if I'm going to use the squared property, I need it to look like this. Something squared equal a constant. And I have that here. I have something. My expression is 3x plus 1. It's being squared. So we have some expression in here. Some expression squared equal a constant. All right, which I do. All right, so I'm going to go ahead and rewrite this over. So once I get that, then that's where I take the square root of both sides, just like this. Don't forget the plus or minus. And so the square and the square root undo each other. So I get 3x plus 1 equals plus or minus the square root of 15. Now you need to ask yourself, can I simplify the square root of 15? Is there a perfect square other than 1 that goes into 15? The answer is no. So I cannot simplify that, so I'm not going to do anything else to this. But I still have to get x by itself. So I'm going to subtract 1 from both sides. Combine like terms, I get 3x equal negative 1 plus or minus the square root of 15. So in the previous two problems we did, if you notice that we did the same thing. So in this case, we added 3 to both sides, right? In this case, I subtracted 4 from both sides. But this one was easier because the coefficient of x was already a 1. See where? So I just got x by itself and I was done. Coefficient of x was a 1. I got x by itself and I'm done. But here, that's not what I have. I have 3x. So what do you think the next step is? Well, right now I'm multiplying by 3. The opposite is 2. Divide by 3. And so you would do something like this. And so I get 3 divided by 3 is 1. So I get x equal negative 1 plus or minus the square root of 15 divided by 3. And that will be your answer. You cannot reduce anything else. Now let me talk about, remind you about some different ways of writing this. So on my math lab, you're going to have to write it as this. So you're going to say negative 1 plus the square root of 15 over 3, comma, negative 1 minus the square root of 15 over 3. Okay? Now there's some other ways of writing this, other ways of writing solution, writing the solution. So remember, you can, since my denominator is just one number, it's just one term, I can say negative 1/3 plus or minus the square root of 15 divided by 3. Now, again, don't make the mistake of saying 3 to 15 is 5, because that's not 15. That's the square root of 15. All right, so be careful. You cannot do that. So don't make this mistake. Don't make this mistake. Don't say the square root of 15 divided by 3 and reduce that and say that's the square root of 5. That's not true. Okay? That's not true. That is not 15 divided by 5. I meant 15 divided by 3 is 5. That's true, right? But that's not 15. That's the square root of 15. All right, so those are not the same numbers. So you can write like this. You could also say like right here. You could say negative 1/3 plus the square root of 15 over 3, comma, negative 1/3 minus the square root of 15 over 3. All right, so different ways of writing that, so just be aware of that. Okay, number 7. All right, suppose the number 7, all right, suppose number 7, I had 2x minus 5 squared equal 24. So 2x minus 5 squared equal 24. Okay? All right. Okay, so if you notice that I do have that expression squared equal a number, equal a constant, so I can go ahead and take the square root of both sides, just like this. Okay, plus or minus, don't forget plus or minus. So the square and the square root undo each other, so I get 2x minus 5 equals plus or minus. Now, I can simplify the square root of 24, because the square root of 24 is going to be the square root of 4 times 6. So the square root of 4 times square root of 6, so that's 2 square root of 6, right? Okay? And so this becomes 2 squared root of 6 right here. Now go ahead and adding 5 to both sides. Combine like terms, I get 2x equal 5 plus or minus 2 squared root of 6. And then dividing by 2, I get x equals 5 plus or minus 2 squared root of 6 over 2. Okay? All right, now, let me tell you where some of you are going to make a mistake at this point. I would go ahead and leave your answer like this because it's really, you can't reduce. See those three terms right here? Counting 1, 2, 3. 5, just as 2. Don't look at the square root. Just as 2 and 2. Those three numbers, 5, 2, and 2, the GCF is 1. So you can't reduce this any further. But this is where people make a mistake. Let me show you what the mistake is. So you have 5 plus or minus 2 squared root of 6 over 2. What people do is they'll remind themselves, hey, there's some 2's here, so I can reduce that. And then they'll say, well, that's going to be 5 plus or minus square root of 6. That's not true. Not true. Okay? So you cannot do that. You see, what you're doing when you do this, you're implying that this denominator is being divided only into this term, and it's not. It's also being divided into this. Because if I broke this out into two parts, y'all agree that's going to be 5 plus 2 squared root of 6 over 2, comma, 5 minus 2 squared root of 6 over 2. And then if I go further and write this as two separate fractions like I did in the previous one, see right here, like these. So if I did that here, do you see that's going to be 5 divided by 2 plus 2 squared root of 6 divided by 2, comma, 5 divided by 2 minus 2 squared root of 6 divided by 2. So what are you missing here? When you make that mistake, you're missing the fact that 5 is also being divided by what? 2. Now, at that point, I can reduce the 2's here, because if I cover this up and I just look at that term, those two terms, the numerator and the denominator, have a common factor of 2. So yes, I can do that here. So that would be 5 halves plus the square root of 6, comma, 5 halves minus the square root of 6. All right. So either one of those is fine. I would have just left it like this on a paper test. In my math lab, though, they do want this. They want you to write it. They want the solution separated by a comma. Don't make that mistake. All right. So you have to remember when you reduce like this, when you do this, you're forgetting the fact that both those terms up here, the 5 and the 2 squared root of 6, are both being divided by 2. All right, so that is a common error. Okay, number 8. All right, let's suppose number 8, we had this. We had 7x minus 5 squared minus 75 equals 0. All right, now ask yourself, is this equation, this quadratic equation, now this is quadratic, all these are quadratic because if you were to fill this out, 7x times 7x is 49x squared. Notice I said x squared. So you have an x squared in your equation. All right, so you want to ask yourself, is this quadratic equation of this form? Does that look like this? The answer should be no, it doesn't. Because I have that negative 75 on this side. So I got to bring it on that side. I got to bring my constant on that side. So then I'm going to add 75 to both sides. And so I get 7x minus 5 squared equal 75. Now that looks like this. So at this point now, I'm going to take the square root of both sides. And then don't forget the plus or minus. And so the square and the square root undo each other. So you get 7x minus 5 equal plus or minus. And then we can simplify the square root of 75 because the largest perfect square that goes to the 75 is 25. So that's 25 times 3. And so I can write this as square root of 25 times the square root of 3. And so the square root of 25 is 5, so you get 5 square root of 3. So that's going to go here, 5 square root of 3. And the next step is to add 5 to both sides because we were trying to get x by itself. And so I get 7x equal, remember you can't combine those, so you have to write it as you see it. So that's 75. I'm sorry, that's 5 plus 5. So that's 5 plus and minus 5 square root of 3. And then how to get x by itself? Divide both sides by 7 and you're done. Leave it like that. X equal 5 plus and minus 5 square root of 3 over 7. Now on my math lab, you're going to write this as two separate solutions. So you're going to say 5 plus 5 square root of 3 over 7, comma, 5 minus 5 square root of 3 over 7. And then if you want to, you can go further. You can write this as two separate fractions. 5 sevenths plus 5 square root of 3 over 7, comma, 5 sevenths minus 5 square root of 3 over 7. Okay? All right, so notice though, in those 8 problems we did on this little part, all of our solutions were either irrational, or they were rational. We had a couple that were rational. Okay. All right. Now, in I'm going to do another review. So, but the other review that we're going to look at, some of those will be imaginary solutions. So you're going to have imaginary solutions where you have that I in your solution. All right. So that'll be the end of this review.